The authority of the inspector and the responsibilities of the electrical contractor depend on the specific codes, standards, and regulations that apply to the project. The National Electrical Code, or NEC, requires electrical installations to be inspected by qualified inspectors. The NEC does not specifically require underwriters' laboratories or all labeling on production machinery. Third-party inspection agencies may have their own requirements that go beyond the NEC. It is possible that the third-party agency has a specific requirement for UL labeling on production machinery as a condition of final inspection. The electrical contractor is responsible for providing code-compliant electrical installations. This includes providing feeding and disconnecting means for the equipment and proper terminations at the control cabinets. The answer to who is right depends on the specific circumstances and contractual obligations. If the third-party inspection agency has a specific requirement for UL labeling, then the inspector has the authority to enforce that requirement. If the electrical contractor is not responsible for providing or labeling the equipment, then the contractor may be justified in refusing to provide the UL labels. Firstly, consult with the third-party inspection agency to confirm their specific requirements. Secondly, if the agency requires UL labeling, determine if the manufacturer can provide the labels or if other options are available. Thirdly, if the manufacturer cannot provide the labels and the electrical contractor is not responsible for them, consider discussing the issue with the project owner or architect. Fourthly, explore alternative ways to demonstrate compliance with the agency's requirements without requiring UL labels on the production machinery. Let's delve deeper into the NEC and its implications for industrial machinery. While the NEC doesn't mandate UL listing for the machines themselves, it heavily focuses on the safety and compliance of the electrical installations that power these machines. This means ensuring proper wiring methods, overcurrent protection, grounding, and disconnecting means. Article 430 of the NEC covers motors, motor circuits, and controllers, which are integral parts of most industrial machines. Understanding the requirements in Article 430 is crucial for any electrical contractor working on these projects. For example, Section 430.22 dictates the minimum ampacity of conductors feeding motors, based on the motor's nameplate current rating and duty cycle. It's not enough to simply run a wire that seems adequately sized. You must perform calculations to ensure it can handle the continuous load and potential overloads. Similarly, Section 430.52 outlines the rules for motor overcurrent protection, specifying the maximum size of fuses or circuit breakers based on the motor's type and full load current. Proper overcurrent protection is vital to prevent motor burnout and potential fire hazards. Grounding is another critical aspect. Article 250 of the NEC provides detailed requirements for grounding and bonding electrical systems. Ensuring that all metal parts of the machinery are properly grounded minimizes the risk of electric shock. This involves connecting the equipment grounding conductor to the machine's frame and to the building's grounding system. Disconnecting means are essential for safely de-energizing the machinery for maintenance or repairs. Section 430.102 specifies the location and type of disconnecting means required for motors and their controllers. The disconnect must be readily accessible and capable of interrupting the motor's full load current. Now, let's consider the role of the third-party inspection agency. These agencies are often hired by project owners to provide an extra layer of assurance that the electrical installations meet all applicable codes and standards. Their inspectors may have a more stringent interpretation of the code or may have additional requirements based on their own internal policies or the specific needs of the project. For instance, they might require that all electrical components used in the installation, such as circuit breakers, contactors, and terminal blocks, be UL listed or have equivalent certifications. This helps ensure that the components have been tested and meet recognized safety standards. In some cases, the third-party agency might require a field evaluation of the entire machine by a certified testing laboratory. This involves a thorough inspection and testing of the machine's electrical system to verify its compliance with relevant safety standards. Field evaluations can be costly and time-consuming, but they may be necessary if the machine lacks UL listing or other recognized certifications. When dealing with machinery manufactured overseas, it's important to be aware of the differences in electrical standards and practices. European standards, for example, may differ from North American standards in terms of wiring methods, component ratings, and safety requirements. It's crucial to ensure that the machinery is properly adapted to the North American electrical system. This may involve replacing certain components, such as power cords or plugs, with ones that are compliant with UL standards. It's also important to verify that the machine's control panel is properly labeled with the correct voltage and current ratings. Mislabeling can lead to serious safety hazards. In addition to UL listing, there are other types of certifications that may be acceptable to the third-party inspection agency. For example, a machine that is certified to the Canadian Standards Association, or CSA, standard may be considered equivalent to a UL-listed machine. It's best to check with the inspection agency to determine which certifications they will accept. If the machinery lacks any recognized certifications, it may be possible to obtain a special inspection label from a certified testing laboratory. This involves a limited inspection of the machine to verify that it meets certain minimum safety requirements. A special inspection label may be a more cost-effective alternative to a full field evaluation. When negotiating with a third-party inspection agency, it's important to be prepared to provide documentation demonstrating the machine's compliance with applicable codes and standards. This may include wiring diagrams, component specifications, and test reports. It's also helpful to have a clear understanding of the agency's specific requirements and the reasons behind them. If you disagree with the agency's interpretation of the code, be prepared to present your case in a professional and respectful manner. It's always best to try to resolve disagreements through communication and collaboration. If you are unable to reach an agreement with the third-party inspection agency, you may need to consult with a qualified electrical engineer or code consultant. These professionals can provide expert guidance on code compliance and can help you navigate complex electrical issues. They can also represent your interests in discussions with the inspection agency. In some cases, it may be necessary to obtain a variance from the local electrical inspector. A variance is a written authorization to deviate from a specific code requirement. Variances are typically granted when strict compliance with the code is impractical or would impose an undue hardship. To obtain a variance, you must demonstrate that the proposed alternative will provide an equivalent level of safety. Finally, it's important to remember that electrical safety is paramount. Never compromise safety to save time or money. Always follow the applicable codes and standards, and consult with qualified professionals when in doubt. A properly installed and maintained electrical system is essential for protecting workers and preventing electrical hazards. Let's discuss the specific types of printing and bindery machinery and plastics blow molding equipment mentioned. Printing and bindery machinery can range from simple paper cutters to complex printing presses with sophisticated control systems. These machines often have numerous motors, sensors, and control circuits, all of which must be properly wired and protected. The electrical contractor must ensure that the wiring methods used are appropriate for the environment, which may be dusty or contain flammable materials. The control panels must be properly labeled and accessible for maintenance. Plastics blow molding equipment typically involves heating elements, hydraulic systems, and complex control algorithms. These machines can draw significant amounts of power and require robust electrical systems. The electrical contractor must carefully size the conductors and overcurrent protection devices to handle the high current loads. The heating elements must be properly controlled to prevent overheating and potential fire hazards. Hydraulic systems can pose additional risks such as oil leaks and electrical shorts. It's important to ensure that all electrical components are properly sealed and protected from hydraulic fluids. When working with any type of industrial machinery, it's essential to follow lockout/tagout procedures to prevent accidental energization during maintenance or repairs. Lockout/tagout involves disconnecting the power supply to the machine and attaching a lock and tag to the disconnect to prevent it from being turned on. Only authorized personnel should be allowed to perform lockout/tagout procedures. In addition to the NEC, there may be other applicable standards and regulations that apply to the project. For example, the National Fire Protection Association, or NFPA, publishes numerous standards related to electrical safety, including NFPA 70E, which covers electrical safety in the workplace. It's important to be familiar with these standards and to follow them when working on electrical installations. It's also important to consider the potential for arc flash hazards. Arc flash is a dangerous electrical phenomenon that can occur when there is a fault in an electrical circuit. Arc flash can cause serious burns, injuries, and even death. To protect workers from arc flash hazards, it's necessary to conduct an arc flash hazard assessment and to implement appropriate safety measures, such as wearing personal protective equipment, or PPE, and using insulated tools. The electrical contractor should also provide training to workers on arc flash safety. Let's delve into some specific NEC sections that are particularly relevant to industrial machinery installations. Section 670.3 covers the supply circuit disconnecting means. This section requires that each machine have a disconnecting means that is readily accessible and capable of being locked in the open position. The disconnecting means must also be clearly labeled to indicate the equipment it serves. Section 670.4 addresses overcurrent protection. This section requires that each machine be protected by overcurrent devices, such as fuses with circuit breakers, that are sized to protect the conductors and equipment from overloads and short circuits. The overcurrent devices must be readily accessible and clearly labeled. Section 670.5 covers control circuit transformers. This section requires that control circuit transformers be protected by overcurrent devices on both the primary and secondary sides. The overcurrent devices must be sized to protect the transformer from overloads and short circuits. Section 670.10 addresses wiring methods. This section requires that the wiring methods used for industrial machinery be suitable for the environment in which the machinery is installed. For example, if the machinery is installed in a wet or dusty location, the wiring methods must be designed to protect the conductors from moisture and dust. Section 670.12 covers grounding. This section requires that all metal parts of the machinery be properly grounded to prevent electric shock. The grounding conductor must be sized in accordance with Table 250.122 of the NEC. Section 670.42 deals with marking. Industrial machinery must be marked with the manufacturer's name, trademark, or other descriptive marking by which the organization responsible for the product may be identified and the voltage, phase, frequency, and full load current. Section 670.58 addresses wiring space. Sufficient wiring space must be provided within enclosures for conductors installed in that enclosure. Conductors must not be more than 75% of the cross-sectional area of the wiring space. Section 670.90 covers safety interlocks. Safety interlocks must be provided on machinery that could cause injury to personnel if operated without proper safeguards. The safety interlocks must be designed to prevent a machinery from being operated unless all safety guards are in place. Let's also talk about the importance of documentation. Accurate and up-to-date documentation is essential for the safe and efficient operation and maintenance of industrial machinery. The electrical contractor should provide the project owner with a complete set of wiring diagrams, control panel layouts, and component specifications. The documentation should be clearly labeled and easy to understand. The documentation should also include a list of all spare parts that are recommended for the machinery. The project owner should keep the documentation in a safe and accessible location. When troubleshooting electrical problems, the documentation can be invaluable in identifying the cause of the problem and determining the appropriate solution. Now, let's get into some practical tips for working with third-party inspection agencies. Firstly, establish a good working relationship with the inspector. Treat the inspector with respect and be willing to listen to their concerns. Secondly, be prepared to provide the inspector with all the necessary documentation. The inspector will need to see the wiring diagrams, control panel layouts, and component specifications. Thirdly, be proactive in addressing any potential code violations. If you know that there is a potential code violation, address it before the inspector arrives. Fourthly, be willing to negotiate with the inspector. If you disagree with the inspector's interpretation of the code, be willing to negotiate a compromise. Fifthly, document all communication with the inspector. Keep a record of all conversations and emails with the inspector. This will help you to avoid misunderstandings and to resolve any disputes. And now let's discuss the ethical considerations of electrical work. Electrical contractors have a responsibility to provide safe and reliable electrical installations. This responsibility extends to all aspects of the work, from the design to the installation to the maintenance. Electrical contractors should never compromise safety to save time or money. Electrical contractors should always follow the applicable codes and standards. Electrical contractors should always be honest and ethical in their dealings with customers, suppliers, and inspectors. Electrical contractors should always strive to improve their knowledge and skills. By adhering to these ethical principles, electrical contractors can help to ensure the safety and well-being of the public. Let's think about how technology can assist with this process. There are many software tools available that can help electrical contractors to design, install, and maintain electrical systems. These tools can help to automate calculations, create wiring diagrams, and track inventory. They can also help to improve communication and collaboration among team members. Some popular software tools for electrical contractors include AutoCAD Electrical, Revit, and Easy Power. These tools can help to streamline the electrical design process and to reduce the risk of errors. In addition, there are many mobile apps available that can help electrical contractors to perform calculations, look up code requirements, and access product information. These apps can be invaluable in the field. Now, let's consider the future of electrical work. The electrical industry is constantly evolving, with new technologies and methods being developed all the time. Electrical contractors need to stay up to date on the latest trends and developments. Some of the key trends in the electrical industry include the increasing use of renewable energy sources, the growing demand for energy efficiency, and the rise of smart homes and buildings. Electrical contractors who are able to adapt to these changes will be well positioned for success in the future. Let's summarize the key takeaways. Firstly, understand the specific requirements of the third-party inspection agency. Secondly, communicate effectively with the inspector and be prepared to provide documentation. Thirdly, address any potential code violations proactively. Fourthly, consider alternative ways to demonstrate compliance without UL labels. Fifthly, prioritize electrical safety at all times. By following these key takeaways, electrical contractors can successfully navigate the challenges of industrial machinery installations and ensure the safety and compliance of their work.